Okay, example 2. So this one, that last one was, like I said, the most challenging one. There were lots of twists. Example 2 is a little more basic. For a given graph of flow rate versus time, there is a flow of 0.6 centimeters cubed with each beat of the heart. If there are 2.5 beats per second, what is the maximum flow rate? So they want to know this point right here. Like I pointed out that, okay, they're going to go and turn things around on us. We're going, the problem's sort of going backwards. What we're going to realize is we need to, okay, we say Q per beat is equal to area 1 minus area 2 plus area 3, right? But then we're going to cancel these two because they're equal and opposite. So it's going to just be area 1, which is equal to 1/2 Q peak, okay, times the delta T of the base, which is going to be equal to 1/2. Well, wait a minute. And in this problem, they gave us Q beat. They gave us the flow centimeters cubed per beat. In the graph, they're telling us the time, okay, in degrees. They want us to figure out Q peak. So we're going to solve for Q peak. Q peak is going to be equal to 2 times the flow of in a beat divided by delta T. Okay? So we say 2 times flow per beat, 0.6 centimeters cubed per beat, all divided by delta T. So what's delta T? It's the base. So it's 240 degrees minus 0 degrees. Now we have to convert. You know what? I'll do it differently. We're going to figure out what delta T is, and then we're going to plug it in there. What's delta T? Delta T base, okay, we call it base, is going to be equal to 240 degrees minus 0 degrees. Then we have to convert it to time, so we have to say TP over 360 degrees, right? So then that becomes 240 over 360 times TP. And what's TP? TP, let's go over here. TP is equal to what? Did they give us TP? No, they gave us 2.5 beats per second. So that's going to be equal to, we'll take the reciprocal, 2.5 beats per 1 second. There's 1 second per 2.5 beats, right? So what's that? 1 divided by 2.5 equals 0.4. 0.4 seconds per beat. That's TP. So I plug that in there. 0.4 seconds per beat. And we get, let's see, 240 divided by 360. 240 divided by 360 equals times 0.4, 0.27 seconds. Okay? And it's going to have this in units of seconds per beat. Okay? So we plug that in there. Okay, let's see. And we're going to get, oh yes, it goes in the denominator, yeah? So we're going to put 0.27 seconds per beat. So now we pull out our calculator and we say 2 times 0.6 equals divided by 0.27 equals 4.44. 4.44. And what are the units? Centimeters cubed. The per beats cancel. Per second. Does that make sense? Is that in the units of a Q max on the graph? Yes. 4.44 centimeters cubed per second is the answer. Okay, that's a much more basic problem, right? What do? We said the flow per beat is equal to area 1 minus area 2 plus area 3. We canceled out the two little areas because they're equal and opposite. All we had to do was figure out the area of a triangle. 1/2 Q peak times delta T. We solved for Q peak, so we have to rearrange. Then we realized we needed delta T. So we had to do a little bit of conversion. They gave us the flow rate. We had to take the reciprocal to figure out what TP was. TP is not that's the full time. That's the pulse time. We need to just take a portion of that, right? So we had to convert. And we got 0.27 seconds per beat was the base of this triangle. Plug that in. We got 4.44 centimeters cubed per second. That is a basic problem that's just been sort of turned around on us. Okay, thank you.